Here we have the sine of theta is equal to 1/2. And we know anytime we're looking for an angle, that's when we're going to do the inverse. So we could rewrite this and say that theta is equal to the inverse sine of 1/2. And we're looking now, we're saying that we know there's a spot over here on the unit circle. And that coordinates wise, we're at square root of 3 over 2 and 1/2. And what we're looking for is where is sine equal to 1/2? And that's our y value right there. And so we know that that angle is pi over 6. And when we're talking about a one-to-one function, that's our only answer. But if we're looking at all the possible solutions, all the possible answers, then we would also know that over here at 5 pi over 6, we also have that same value. Now we're at negative square root of 3 over 2 and 1/2. And again, theta, our inverse sine, would be equal to 1/2. So we could also say then 5 pi over 6 would be a possible answer as well. But what if we were to take a lap? Remember, what this makes the sine wave, we have lots of values where it's equal to 1/2. Because if we take a lap, we're right back to this point. And if we take another lap, we're right back to this point. So really, I could say if I add 2 pi, so that we're talking about not just pi over 6 and 5 pi over 6, but if I add a lap, I add 2 pi to that, then the value 13 pi over 6 would also be a solution. And if I add 2 pi to this value and I take a lap and I come right back to here, then 17 pi over 6 would also be an answer. And I could take another lap on both of those. And I could keep going and going and going, where I could just multiply by some value k, where I just take as many laps as I want, and I could continue to have solutions where sine of theta is equal to 1/2. So for example, 25 pi over 6 would also be a possible solution. There are many, many solutions because of that sine wave. And if we don't worry about it being a one-to-one function, then we have an infinite number of possibilities for this angle where sine of theta is equal to 1/2. For this example, we have 4 times the cosine of theta minus 2 times the square root of 3 equals 0. And if we're solving for theta, first we would add 2 square root 3 to both sides. So we have 4 times the cosine of theta is equal to 2 square root 3. Now we can divide by 4. So the cosine of theta is equal to square root of 3 over 2. The 2 and the 4 would simplify. And now we're taking the inverse cosine. The inverse cosine of square root of 3 over 2. Now we know that we have that same value then. We're right back here at pi over 6, where our coordinates are square root of 3 over 2 and 1/2. And so that would be one of our solutions. But again, if we look at that same triangle flipped over here, if we're not worried about the one-to-one function, then 11 pi over 6 is also a solution. Now we have square root of 3 over 2, negative 1/2. So that gives us 2 values. And again, we could take a lap. Going from this point, take a lap, right back to 11 pi over 1, right back to 1 pi over 6. So that could be a possible solution. So what we're saying here is that theta not only is equal to pi over 6, but it's also however many laps we take around the unit circle are all also values where the cosine of theta is going to be equal to square root of 3 over 2. We could also talk about the point at 11 pi over 6 having that same value, square root of 3 over 2 for our cosine value. And again, however many laps we take around the unit circle, we go back to those same values because of that cosine wave. And however many times it's intersecting, we have multiple answers. So for example, we would say on this, of course, the pi over 6 and 11 pi over 6. And if we take a lap, then that would mean 13 pi over 6 is also a value. Take a lap with our 11 pi over 6, so we're adding 2 pi to that. Takes us to 23 pi over 6. Let's add another lap to the 13. That puts us at 25 pi over 6. add another lap to our 23 here. That takes us to 35 pi over 6. These are all possible solutions where our inverse cosine is equal to square root of 3 over 2. For this example, we have sine of 3 times theta plus pi over 18 is equal to 1. First thing we would do is inverse sine on both sides. So we would have 3 theta plus pi over 18 is equal to the inverse sine of 1. Now we know the inverse sine of 1 is equal to, or our angle where sine is equal to 1 is at pi over 2. And if we're talking about all the possible solutions, then that's when we're going to add 2 pi times k, whatever constant value we are going to multiply, however many laps we're going to take to get back to that same angle. And this is all equal to 3 times theta plus pi over 18. Next step now, because we're solving for theta, is to subtract pi over 18 from both sides. So when we do that, now we have 3 theta is equal to, and I'm going to take pi over 2 minus pi over 18, and that we can simplify. We need to get a common denominator, and we're still going to then, whatever that angle ends up being, take a multiple laps around to get to that same angle. So if we think of this as 9 over 18, now we can subtract those, and so we end up with 8 pi over 18, which reduces 4 pi over 9 plus 2 pi times k. That's equal to 3 times theta. So from here, now we're going to multiply by the reciprocal, and when I do that, I'm going to multiply this entire value, 4 pi over 9 plus 2 pi times the 1/3. And we're still taking this times k. Because that 3 times theta means we're going to be going around that circle faster. So it is going to affect this period here. So what we end up with then is we multiply here. We're going to get 4 pi over 27 plus 2 pi over 3 times k. And that would be our multiple solutions for theta. Now here's a similar type of problem. Go ahead and solve this for theta and then check your answer with what I do for work. Okay, so our first step, we're going to take the inverse sine of both sides. So we have 2 theta is equal to the inverse sine of -1. We know that happens at 3 pi over 2. And of course our multiple laps, so we're going to add 2 pi times k for all those multiple laps around. And that's equal to 2 theta. From here we're dividing by 2 or multiplying everything by 1/2. So theta is equal to, so we have 1/2 times 3 pi over 2 and 1/2 times our 2 pi times k. So here we end up with 3 pi over 4 for our angle plus 1/2 times 2 gives us pi times k for all those laps around. So our multiple values of theta would be 3 pi over 4 plus pi times k. Here we have the secant of 3 pi over 2, or 3 theta over 2 is equal to -2. Again, secant we could think of in terms of cosine. So cosine of the same angle is going to give us the reciprocal, so that would be -1/2. And now we can solve for theta from here. We'll take the inverse cosine of both sides. And we know that the inverse cosine of -1/2, we have 2 places on the unit circle where that would be true. So we have 3 theta over 2 is equal to, we know that the inverse cosine of 1/2 is equal to 2 pi over 3. And then we also have inverse cosine of -1/2 is also equal to 4 pi over 3. And then we're taking those multiple laps. So 2 pi times k on both of those. And now we're solving for theta on each of these. So if I just work on this side, I'm going to multiply by the reciprocal here. So we have theta is equal to 2/3 times 2 pi over 3 plus 2/3 times 2 pi times k. So here we end up with 4 pi over 9 plus 4 pi over 3 times k. And on this side, we multiply by 2/3. Now we're going to have 8 pi over 9 plus 4 pi over 3 times k. So those would give us all of our possible solutions for theta. For this example, we have 4 times cosine squared of theta minus 3. Again, we're solving for theta, so if we add 3 to both sides, we have 4 times cosine squared of theta is equal to 3. If we divide by 4, cosine squared theta is equal to 3/4. And now from here, what we want to do is we're going to take the square root of both sides. So we have the cosine of theta is equal to plus or minus the square root of 3/4. This we can simplify. What we're looking for then is the plus or minus square root of 3 over 2. And now we will take the inverse cosine of those two values. So theta is equal to the inverse cosine of both a positive square root of 3 over 2 and a negative square root of 3 over 2. And we have 4 places on the unit circle where cosine is equal to that. So that would give us pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.